Okay, good afternoon. I don't have much time, but we had talked about the empty set being the subset of every set A for all sets A. By the way, you can use this notation for all, that means for all A. And the upside down A is for all. All right, so this is to prove. So it goes like this, technically. To prove any subset is a subset of another set, take any x in that set and show that that implies that x is in the set that it's a subset of. Well, there's no x in here. This part is false. So then this statement is true. And that is, so it is vacuously true. Now that's not satisfying. So basically, when this is false, this is automatically true. That's a fact about implications. So there's other ways to look at this. Is there any, for example, one way people like to think of this is, can you find any element in here that fails to be in there? Like yesterday, we had a set 1, 4, and we compared it to the set 1, 2, 3 in the previous video on sets. And we said this is not a subset of this because 4 is not in there. So can you find an element in the empty set that's not in the set A? And you can't do that. And so that's why this makes sense. Another reason this makes sense is now whenever you do A implies B, if you want to show that A implies B, you could show that not B implies not A. Now that works better in my opinion and is more understandable, because if an element is not in A, it's for sure that an element is not in the empty set because every element is not in the empty set. So in other words, if an not x in A, x is not in A, so x is not in A, x is not in A, that implies automatically that x is not in the empty set because nothing's in the empty set. And so I prefer to explain it like that. Some people say that one way to understand this, and I'll link the thread in the video underneath the description, that the best way to understand vacuously true is if the original statement really does not make any sense of the conclusion. Somebody gave an example that's similar to me when if I say to my wife, "You're my favorite wife." Well, I only have one wife, so it's vacuously true. If I said, "You're my worst wife," that would be vacuously true too. But I never say that, of course. I say, "You're my favorite wife." And but the reason is, if you make a list of my wives, it's vacuously true because there's nobody else on that list. So she's automatically my favorite wife. So that is, in short, the quick way. So understand vacuous truth by that the empty set is the subset of every set. Now let me tell you why this makes sense. You know, I always have to add stuff in these. So we have that the empty set is the subset of every set. But let me show you something. How many subsets does the set with one element have? It has the empty set and then the number 1. So there's 2. That's 2 to the 1 is the number of them. If I have 2 numbers in there, then I have the empty set. 1 is a subset. 2 is a subset. And 1, 2 is a subset. How many do you see here? 4. 2 elements. 2 to the second. So in general, if you have n elements, I can prove this in some other video if you want me to. The number of n elements in a set then there are 2 to the n subsets. The reason I threw this in is if the empty set is not a subset, this does not hold. And the way to prove this is essentially to use, say, a binary number 1 when the element is in the subset, and a binary number 0 to say when it's not in. And so you can do that with any length set. There will be 2 to the n possibilities with the 1s and the 0s using multiplication for the number of possibilities of subsets. That's a summary of actually the proof of that. Well, the case of 0s, when none of them are in, needs to be included to make this work out to 2 to the n, and that would be when none of them are included, that's got to be the empty set as a subset. So this is an intuitive reason, probably hardly anybody ever says this, of why the empty set should be the subset of every set. Because this makes sense with that. But the proof was in the vacuous proof that I did. And I think doing, instead of A implies B, not B implies not A, is the best way to prove that the empty set is a subset of any set. Thank you.